Hey and welcome to a slightly different video. So this video is about fractals, and on the right side you can see an editor window with shader code inside. So the thing that is interesting to us is only the void main, where it just uncommented the Mandelbrot set, which we are now going to plot. So on the left side I'm going to start a GPU based program which allows us to plot the Mandelbrot set. So actually this is a full HD plot, but unfortunately I'm running this on a 4K screen. So I think the Mandelbrot set is pretty common to some of you because it's the most common and widespread fractal you are going to see on YouTube. And there are 3D representations and all the stuff, but the plain old 2D infinite zoom into the Mandelbrot set is kind of, you find it everywhere on YouTube. It's nothing special, so I'm not doing much coverage on the Mandelbrot set. The only thing I want to point out is that there is a specific way the Mandelbrot set is being created, and that is iterative. So you are going to repeat a certain mathematical operation a few times on itself, which is generating this very complex structure. So what I'm going to do now is I back comment the Mandelbrot set, and I use the more or less same method the Mandelbrot set is created, but instead of the power 2 function I'm going to use the exponential function, and we will get a different fractal. So let's take a look at this, and here it is. The fractals are actually controlled with the mouse, so you can pan up and down and left and right, and you can scroll using the wheel. So I'm going to say this because maybe I am going to make this program public, which I called Shader Toy. I don't know why. There is a website called Shader Toy, and I was somehow inspired by it. So I'm going to zoom in to some area of this exponential fractal, and it looks pretty different from what you saw in the Mandelbrot set. So there are structures that look like scorpion tails that are coming out of everywhere, and the coloring here is pretty primitive. I'm just using grayscale ramping and iteration traps. So how many iterations you need to get to a certain value, which is quite boring coloring, but it's the easiest to implement, and it works for every fractal. So what you see here is kind of interesting part in the exponential fractal. So this fractal is actually pretty rich in differences. So there's not this kind of all looking the same fractal. There are regions that really differ from each other. And the more complex these fractals get, the more differing regions will be in there. So later we will see some other fractal which exhibit this property even more. So there will be even more regions that differ very strongly from others in the fractal, giving it much more complexity. Unfortunately, I'm limited to floating point precision here, which means that we can't zoom in super much. So you see here, this region is quite different from everything around it, and it's looking like some flower kind of structure. And you're not going to find this anywhere in the other regions, so this is pretty specific for this particular point in the fractal, and if it would zoom in, it would probably repeat down to infinity. And you can nicely see these arms that are coming out of each other, making it repeating on and on. So we're going back out, and once we check this area, we can see that it's only a very small part in this huge structure, and the area here on the right side is very, very different. It does not show these flower-like patterns. Instead, it's looking like some geometric intersection, everything in a spiral, so it's kind of different pattern here. I pretty much like this fractal, and the cool thing about these things is you can combine them with each other. I've already put some combinations in the shader code. So if I'm going to make this public, the only thing you need to know is that you have to backslash it to comment and other way to uncomment by just removing the backslashes. Or forward slashes? Yeah, they're forward slashes, sorry. So finally I'm going to comment the complex E function again and uncomment a combination of two fractals. So I included a huge range of different functions which can be fractalized somehow, like the zeta function, the potency functions, geometric series, and a lot of other functions. This, for example, is geometric series, which exhibit some fern or tree-like structure, which is quite amazing. However, some structures here are referring more or less to the Mandelbrot set. But all in all, there are still a lot of differences to the Mandelbrot set in these fractals. But in some parts, at least this fractal here is pretty closely related to the Mandelbrot set. But there are still regions that you don't find them anywhere. The Mandelbrot set, like something like this. It's looking like some sponge pattern. Here you can see some, I actually think this is one of the most amazing images in this fractal. It's looking like some Milky Way or star strip. And finally, I'm going to combine them. I'm going to combine the complex geometric fractal with its inverse fractal. If you are interested how they are mathematically defined, you can just look in the code that is in the above section of the editor. And they are basically a combination of Mandelbrot sets, so to say. The complex E function is pretty different from them, however, it does not have to do anything with the Mandelbrot set. And since I'm doing a lot of calculations, my graphic card is somehow at its limit now. Especially it's a full HD image here. You can't just see it in HD because I downrendered the video. And it will have pretty hard times on calculating all this, but it seems to work more or less acceptable. It is not the newest graphic card I'm owning here. But maybe in the near future I'm going to upgrade it and do some better, maybe double precision videos here. But this would probably need some implementation of something else in OpenGL. So we are actually at the end of the video. Hope you enjoyed it, and I think this is one of my favorite fern-like structures. And the next video will be about chemistry again. Hope you liked this excursus. Thank you for watching.